everyone, welcome to Grainchat. Today we look at process of grain cooling. We are Joe Sontag and Hoàng Uyên from Sontag Concern.
Welcome again to our Grainchat, Dr. Claus Braunbeck from FrigorTec in Germany.
Hello.
Hello, Dr. Claus. Today I have another question for you. We often face the statement that grain cooling had a vast power consumption. Dr. Claus, please bring clarification to this statement.
The statement is usually based on the imagination that cooling is energy intensive. However, referring to grain cooling, it must be seen more specific.
Please go ahead and give us a better view on that.
First of all, grain cooling is not a permanent process, which is operated throughout the storage of grain, but only used when the grain is too warm, which means for an initial cooling and later a short refreshing if required.
That limits the operation time, but what else is to consider?
The efficiency of the heat transfer from the grain to the cold air is essential, and that is why grain cooler use only a limited airflow, unlike a ration. Grain has a low heat conductivity, and therefore sufficient time is required for the heat exchange. The low airflow saves cost and avoids waste of cold force.
That makes sense. That as cold air mustn't be kept in use, but that's even all, right?
Indeed, the most important effect is achieved by preventing more heat release from the grain, as respiration is decreased by lower temperatures, which cuts the operation time additionally.
What else will cut the operation time to save energy?
The grain's moisture content plays another role. If moist grain, for example, with 16% MC is intentionally cooled, its MC will reduce by the physics of air during grain cooling. The water evaporation will bring additional cooling force to shorten the grain cooling process. In addition, it considerably cuts the drying cost of grain.
Wow, that's really a win-win for the grain handling, in particular for the rice sector. But what are the actual values of energy consumption?
There are many parameters which play a role, like grain condition, ambient weather, difference of initial and final grain temperature, as well as the bulk storage facility. And last but not least, the design of the grain cooler.
Please give us an example to get some facts for the audience.
Okay, assuming the following example, like a temperature reduction by 15 Kelvin at a moisture content of 16% and a static pressure drop of the bulk storage for the blower by 1000 Pascal. Then the power consumption to cool 1 ton of grain is around 6 kilowatt hours at tropical climate condition at an average temperature of 30 degrees centigrade and an average relative humidity of 70%. At moderate climates, it's even much lower.
Wow, 6 kilowatt hour per ton is amazingly low.
This is based on the experience of customer using the highly efficient Granny Frigor, and can't be generalized to other brands, as the design is critical to the power consumption as well.
Thank you very much for sharing the details, as well as bringing a new light into the power consumption of grain cooling.
You're welcome. Thank you for the Grainchat.
Thanks again for joining us, Klaus.
Dear audience, please feel free to contact us if you would like to address another topic of interest or send us your comment about today's chat. Thank you.